Hi folks, you're welcome again today to this tutorial which is based around a development question in the Graphics in Design and Communication DCG book. Alright, so this one here is question 8 and it's on page 200 for any of you that do have that book. Now the question itself I have set up here. I have the elevation. It's a rectangle based pyramid, as you can see, and it is truncated, so it is cut at an angle, as you can see there. I suppose to get straight into it, the key dimensions, everything are given, so there should be no problem drawing what you see there on screen. I have the height here of the apex that I've called O. I have the height here of point H, as I call it. We're given this height here of G. Actually, I haven't wrote in there. I think it was 16 millimeters off the top of my head. And you're given the size of the rectangle in plan. So from that information alone, you should be able to complete the elevation and the plan as you see it there. Okay, so just over here on the right hand side, another little tip I suppose when you're doing your questions. I know you might be quite pushed for time in exam situation, but try and get a general little quick freehand sketch of it and what you think it's going to look like on paper, and even the solution if you wanted to do a quick freehand sketch over here, just to kind of clear your head as regards to what you think it might look like. And you're not going to be docked marks for putting your sketches there. You know, if anything, I think it adds to the page itself. Okay, so excuse me, I've labelled my points here first of all, A, B, C and D, which is the base of the actual pyramid itself. So that's the base here on the ground. You see point D and C. As I'm looking in from the front here to see the elevation, I see D and C, and point A and B are directly behind those. Likewise with points H and G, H and G here in your elevation, and point E and F are again directly behind those. So they are hidden behind those, although I haven't them labelled here. Right, so the first thing we need to do here for my development, I suppose these differ from a development that might be straight up, I suppose, solid along the sides. In previous questions I did, where the side of the solid might be straight up rather than tapered in at an angle. Okay, the difference that makes is when they are straight up, if you like, a cylinder or so on, you know, you can come across here in your XY line and basically fold that out along the XY line with each surface. But because these guys are tapered in at the angle, as you see here, of the pyramid, it's not necessarily going to be like that. Okay, so it just looks a little different on paper, but again, once you do one or two of these, you'll be able to understand that a lot more. Alright, the first thing I'm going to do here, after my labelling, I want to draw, I'm going to draw the full pyramid. First of all, you can see the light lines in here, and the next thing, I want to get the true length of this line OC. Now OC is here in plan, is same length as OB, OA and OD, sorry. So to get the true length of that, I'm not actually looking at it here in the elevation, and the reason I'm not looking at that in elevation is because it's actually sloped away from me. Okay, it's sloping away. If it was a vertical surface as you look straight into it, yes, you'd see the true length of it, but because it's sloping away, as you can see here, this line in plan, I'm not seeing the true length, and I'm also not seeing that in your plan view. Alright, so the way we do that is we draw it in such a way that we are looking at 90 degrees to it. So I'm going to do that from the plan here. From the plan, just going to get my compass, and I'm going to set it to the length of that line as we see it in plan. So that length of that line, OC. Alright, so essentially what I'm doing is getting this line in elevation and I'm swinging it around. Okay, so I'm going to rotate that up until it's horizontal with point O here, and I'm going to project this guy out. Okay, so I project it out from O horizontally, which is parallel to my XY line, which essentially is parallel to my vertical plane. Okay, I'm going to project that up to the XY line. Okay, so projecting that up to the XY line, just put little indicators in there, and from there, that's the position of point C when it's rotated around. So if you can imagine simply what I've done from that angle, I've rotated around to a position that we're actually looking to it at 90 degrees to it. Okay, I'm just going to draw that line in there, and I'm going to just dash that there just to highlight it that that is my true length. I'll write in here TL, it's the true length of the line. OC. Okay, so that gives me the true length that I can work off for my actual development. Alright, so keep in mind with the development, when you have the development complete, you should see the true shape of each surface as well as true lengths and true widths and so on. Okay, so what I'm going to do, where you start this on the page is totally up to yourself. I generally like to come parallel to that in these situations. Just bring that across parallel, just throw it in here. Okay, so we have a light line now, parallel. I'm just going to label point O from point O, as I said there, and I'm going to come across here as well from the XY line just to get the actual length of that line. So that's it there in this view. You have O and C. Okay, so that's going to help me determine, I suppose, the length of all those other elements, if you like, or edges on your pyramid. So O, C, O, D, and so on. Alright, so the four of these, as I said at the beginning, are the same length. So what I'm going to do from point O, I'm just going to swing an arc at that length. O to C, I'm just going to swing an arc around there just for now, and I'm going to use that for my development itself, just to get me set up. So that arc, O to C, just swing it around as much as you think you need it for now. Alright, again, depending on which way you decide to lay out the question and where you need to start, or where you decide to start, it might look different than the way others do it. So if you have it done different than me, doesn't necessarily mean it's wrong or incorrect, just that you might have opened it up, if you like, using a different approach. Okay, the next thing I'm going to come here, I now have point O and C. So if you look here and plan point O and C, that joins across to B. Alright, so we know that B is somewhere along this arc coming from O, but where exactly is it? Alright, so what I'm going to do, I'm going to come down here to my plan. I'm going to get the length of the line BC. Okay, from the plan, because that's horizontal line, I know it's the true length, and I'm going to swing an arc from C to get my point B. Okay, and that there gives me my point B on that arc. So now I'm able to draw the next. I'll draw this a bit lighter. Drawing the next generator, next corner, if you like, for the pyramid. Alright, what comes after B, if you follow your way around the plan, I'm going to get the length of B to C. So again, in plan, the true length of B to C. I'm going to swing that arc from B. Okay, from B there to get point C. Okay, and from C to D is opposite that. That's going to be from C to D in the other direction. It's the same length. So I'm just going to swing that while I have the compass set to that. So that's your point D here. Alright, and we have one missing, so I need to get this one here from A to D. Again, set the true length, compass to the true length from plan. I'm going to go I started from C to B. I've called this one C, sorry, that's actually A. So from A back to D, I'm going to go this side. Again, you could go this side from D to A. I'm just going to do it over here so it's not too cramped up on the actual drawing itself. And that gives me point D here. That will in turn join back to your point D over this side. Okay, so what I have there is basically the base lines of my pyramid. I'm going to draw those in now and join them back to the apex. Okay, so that's my 4 sides in place. You can see from C to B to represent this surface, B to A represents this back surface, A to D represents this surface, and D to C represents this surface over here. And again, as I said, they all go back to the apex. So you have, I suppose, the general shape of the full pyramid before it's truncated, drawn out there as a development. So the next thing I want to do, if you look at the question here, it's actually truncated, so it's basically it's cut at an angle. So I want to get them cuts and, you know, transfer the key points over to my actual development here. So the way we're going to do that is going back to our true length line, okay, which is the length of these generators. Alright, as I rotated those lines here in plan, my point H, if you like here, doesn't change in height. My point G is the same. So I'm going to bring those across until they hit my true length line. So point H, just to put an arrow on that. While I'm at it, I'm going to do point G. So you see this guy here. Now I come with my compass again. From the apex, you could go from the base if you want, but from the apex, the best practice to get into. Take that length from the apex down to point H. Okay, so that length, and you're transferring it over here. Now this is where your labeling comes in handy. Okay, very easy to get it mixed up if you haven't your labeling done appropriately. So I'm going to look here. The height of point H is these two guys, so it's on the line OD and the line OA. Alright, so I'm going to come to line OD. Now don't forget I've OD in 2 spots here. That's 1, 2, and we said on the line here, corner OA, and that'll give you point E. So OA gives you point E. Okay, so before we go any further, I'm just going to mark those just so we don't get them mixed up. That's point E, and on the line OD gives you point H. And again, when that corner meets up with the same line this side, that'll give you point H. Now I'm going to come to G, locate the heights of G and F. So same thing again, remember we're working off the through line here. So from O down to G, and again point G is on the line OC, so this line OC, we'll mark off that point, and point F is along the line OB, so OB is here. Okay, so that gives you, in turn, that gives you this line across here. So if I join those two, which are, what should I say, G and point F. Okay, F then on the cut surface joins back to E. If I join F back to E, E comes across to H. Now H is over this side as well, and H then comes back to G. Okay, so H comes back to G, and that there gives me the actual cut surface of the truncated pyramid, if you like. That gives you the development of the actual pyramid itself. Okay, so I'm just going to highlight that now, leaving the dashed lines where they're supposed to be for the folds. I'm just going to draw it in heavy just to make it stand out that bit more. So as you can see here, I shaded it and coloured in my lines that bit heavier to make it stand out, which it does straight away. And again, you can see why the points are relevant when you're labelling them from your plan and elevation initially. Alright, what I've done here is shaded in the blue areas. That's 1, 2, 3, 4 surfaces. That's the 4 sides, if you like, of the pyramid itself. So you can see down here how they might differ, you have the 2 at the back as well, or how they might look in your actual development, just to get a better image of that. Now the next thing I'm going to work on is getting the true shape of the top surface, which here is highlighted in pink, and the base surface as well. Okay, now I suppose the handy thing here to remember is the base here is a rectangle, so keep in mind exam situation, you're going to be under a time constraint, so why not get the simple ones done first. So the base here is a rectangle. You can see I'm going to attach it here where I left this dash from the line CB, which is this line here. So I'm just going to come out at 90 degrees to C and B. I'm going to come out 52 millimeters and I'm going to finish off that rectangle. Okay, so that's my base done. Just going to shade that in pink just to again highlight the different surfaces. As regards the base here, I did say it came out 52 millimeters, which is the actual length of the line AB, which is the base of it. Okay, so it came out there. From point C, I came out to D, and from point A, I came out, which gives me from point B, I came out to point A. Again, they are at 90 degrees there because it is a rectangle hinged on that line. Now, another way to check that, because this line AB here is a true length as well, so essentially when your development folds up, these 2 points A's should meet. So you could also rotate that distance from point A there if it's your true length. Okay, you can rotate that around in order to get point A up here. Okay, so likewise with the point CD, okay, that could also be rotated here to get that measurement also. Okay, so there's both, you could do that both ways there. Alright, so just keep that in mind. So going to move on to you could highlight and label your surfaces as well if you want. I'm going to move on to the top surface here itself. Now again, there are different ways to do this, so I always try and do it the most simplistic way. If you look at this surface, first of all, the lines FG and the line EH, they're horizontal lines in reality. How do I know this? Because I can only see a point view of both of those lines here. So HG, I can only see a point view of it, and GF can only see a point view as well. So that tells me they're horizontal. So if they're horizontal in any of those views, I can get the true length of those there. Okay, so hence if you want to double check that, you see the line GF in this question, GF, that's the true length of it, so that should be the same as the true length over here. Alright, so the handiest way to do this, I'm going to get the midpoint of GF, which is already here, brought out from the apex. I'm going to locate it here. Alright, I'm going to project up at 90 degrees to that to get this center line. Okay, so I'm going to project up at 90 degrees to it. That should be along the line there of the apex to get that center line. Alright, now from here it can be done different ways. So I suppose the simplest way is looking at my different options. This line here, I'm going to call it line, we'll call it 1, 2. Okay, so this line here down the center of the object. That line is essentially this here, from this point here, which is behind H, if you like, down along that cut surface to G. So it's in the middle of the surface. Alright, it's not the same length as the actual line HG, because keep in mind, HG is sloping away from us, that two angles if you like, sloping away from us, that line, so it's not giving us the true length of that. The line I'm looking at, 1, 2, is the line that goes down the center. Look here in the sketch, it goes down the center of the actual solid itself. So that in turn gives me the true length of the line 1, 2. Okay, so this is one way you can do it. Okay, so that's giving me the true length of it. If I come up from the line GF, which point 2 is on, let's mark that. Up from the line GF, which is your center line, that will give me point 1 up here, and I can now draw a line through that point 1, which is horizontal also, so which should be parallel to the line GF. Okay, so now we know somewhere on that line will be my point H and E. Now the quickest, I suppose, and handiest way to get that is to go back to my plan view, to where I have my number 1 as I have it labelled. Again, your labelling is key. Measure out to E and to H, should be the same both sides. Along that line, come back to 1, out to E, stroke line the other side, out to H. That gives me my 2 points here, H, point E, and simply join them back to G, H to G, E to F, and that is basically your surface development complete. Okay, so that's the true shape of the top surface of the structure, or of the pyramid. Right, I'm going to shade that in again just so it does stand out. Okay, so again, if you want to label them just to make it look that bit better and to simplify it for yourself as you run along, you see the full development there, the base and the top, and you have 1, 2, 3, 4 different surfaces. Alright, you have your 4 surfaces, your top and your base here in your pictorial view. Now an alternative way just quickly to go through that, as opposed to what I said here being the true length line of point 1 and 2, which I'll just put in there just to clarify. Okay, if I wanted similar to this line OC, what I did in the beginning, this line OC, I rotated onto a horizontal line here which is level with point O, the point of rotation, projected up to the XY line and back up to O. That gave me the true length of OC. Okay, I could do similar here if I want to come from point H out horizontally. This is to get the true shape of the top surface. I could swing from point H, you can see that there, set my compass to G, swing it out to that line, okay, swing it out to that line, project it up, but this time I must project it up onto the height of point G itself. Okay, let's project it up onto that height with a pencil, where point G initially rested. That gives me a point here, and that then gives me the true length of the line HG. So it's just a slight bit longer there in reality. True length of that, you get that on your compass, that true length. I'll do it here just to show you. Again, there's different ways of doing this, so don't be too stressed about your way being different to mine or so on. Get the true length of HG from the point G you have here originally. Once I got this horizontal line, I can also swing the arc here and it should be the same there, striking through point H, and on this side through point E. Okay, so if you're accurate, that should be the same. There's 2 ways of doing it. You know, both ways are correct, unless you're I suppose you could be asked in the question showing the true length of the line HG, get the true shape of the top. Alright, so hope that has helped, guys. Just again, don't forget to label your views just from a presentation point of view. It's nice to add these like extra little touches. It does help, and you know, if you want to increase your chance of getting full marks, I would recommend doing all that. Alright, I also have a little model here of the 3D view, so that's the model of it itself, the development. So if you wanted to check it, you could cut it out as you've seen here, which I have done, and that shows the actual shape of that development, you know. And the one way I'm supposed to check if it is right is that you can fold it up like you see here, that does form the shape we're looking for. Okay, so again, guys, any questions, you know, don't be afraid to shout. I do encourage to give a thumbs up on YouTube if you're watching on YouTube, or also you can add a comment, or any comment or request that you like. It's always good to get feedback, so I welcome that all the time. Thanks, guys.